Hey everyone, welcome to TechBrick YouTube channel. This is Mallikarjun. Today we are going to discuss about how does map works internally and also a few of the exceptional cases which we need to take care while using map data structure. So let's get started. Let's consider a map M1 which has key type as string and value type as int. Usually whenever we create a map, it won't store key value pair in its memory. Instead, it holds address of hmap data structure. Here, hmap is a struct which holds length, buckets, hash function, seed, and many more attributes. Length is nothing but how many key value pair does M1 map contains. And bucket is an array of bucket which holds address of each bucket. So bucket might be in the form of B1, B2 till Bn. Each bucket is capable of storing 8 key value pairs in it. We will discuss about this in detail, and hash function and seed are used to create a hash value for each key. Let's consider a map which contains 18 elements, as we already know that the map object contains address of hmap struct in its memory. Let's look into hmap which contains length as 18, nothing but the number of key value pairs in that map. And we have buckets which is an array. So here we have a bucket b1, b2, b3 whose address is stored in buckets array. So let's think we have a 18 elements, right? So the number of bucket will always depend on 2 power n. So here 18 elements. So if we have like 8 elements, nothing but 2 power 0, that is equal to 1 bucket. Similarly, if you have items nothing but the key value pairs from 9 to 16, then 2 power 1, that is nothing but 2 buckets in order to accommodate 16 elements. And similarly, when we have like 16 to 24 items, then we will be having 2 power 2, nothing but 4 bucket. So in this scenario, like we should be having like 4 buckets, but for a representation, we are showing just 3 buckets. So now let's look little deeper into single bucket, which will contain map header, which will hold hash bits used for comparing key value pairs, which are h1, h2 till h8. Also, we know that each bucket will hold 8 fixed key value pairs, and if any extra key value comes to the bucket when the current bucket is full, then it will create a new bucket and stores a new value in it. But in such a scenarios, overflow pointer will point to new bucket when current bucket is already full. Nothing but it already filled with 8 key value pairs. Let's consider a map where M1 map of string of int. So this is, we already know that this is a nil map. So as soon as this map created, right? So the memory at like M1 will be, because it will be having like a zero, nothing but nil or null you can say, instead of having a underlying h map, because this is a nil map. So if the map is not initialized, the address will be like it will be empty or nil or null. So whenever we create like map, let's consider M2 with by using make map of string of int. In this case, the memory at M2 will be holding the address of hmap, right? So this is fine. Now we'll try to add some item to hmap as well. So let's consider like a Zan is equal to 25 and M2 of like Harry, so is equal to some, let's say like 35, 37. fmt.println of M2. So this is fine. Now if I simply print it, it is anyway going to print like M2. And also, as we have already discussed that map map is a reference type, but map actually not a reference type, but it behaves as a reference type. But there are like few scenarios in which map fails to act as a reference type. So we will discuss that scenarios. So first we will write like one function and we'll pass M2 to it. We will try to define that. So instead of taking like M2, we'll simply take it as map2 just to differentiate, and I will simply try to update it. So Zan is equal to 27. Also, I will try to add, okay, it's not map, it should be map2. And like one more I will try to do. I try to add one new key called Luis, and let's like say some 24. Perfect. Then, as we already know that map is a reference type or acts as a reference type, so we will try to run it and to see. So it should have like a Zan updated to 27. Perfect. And then Lou is added and Ari 37. So in this case, it acts as a reference type, right? So if you see here as well, the memory address of this M2 will also hold, sorry, map 2 will also hold the same edge map, and even here as well. So this is fine. Now we will see one more magic here. So map 2 is equal to nil. So in this case, what will happen? So if it is really a reference type, right, then as soon as I print M2, it should actually give me empty map, or probably, sorry, not an empty map, sorry, nil map. Let's see. But still, if you see, it is containing these two, even though I am like assigning map2 to nil. This is because here the address of map2 will contain empty, nothing but 0. The address will be 0, nothing but it's nowhere pointing to h map. Having said that, so here as well as here, in even here as well at this place, so the map is pointing or holding the address of h map. So here also it is updating. So here it's updated, here as well it's updated, and so thereby it is actually reflecting here in the M2. And here, as soon as we are making it to nil, the memory address of map2 is like again become nil, but it's not going to make any changes to h map or maybe even M2, because like the memory address of like M2 is still pointing to h map, and the h map till here we have updated. That's the reason it's actually not giving any nil. Instead it is actually giving us like whatever the expected values. Just that if you want to receive nil, you need to return the map. So let's consider like map string int, and if you are returning this map, right, return map2. And if you again you have to take that map as well, let's consider that as m3 instead of m2. Then in this case, if I run it, then it will be a nil map, because we are returning that nil map. That's the reason. So if you're not returning, then till here it will be keep updating the h map, and thereby it was reflecting. So this is fine. Now we will think here, so far like we are passing m2, right? This is a normal map, it's not a nil map, I mean to say. But let's pass m1, that is a nil map, and let's see like what is going to happen. Clear? So if you see, it's panicking. What should be the reason? The reason is because we are passing a nil map, and as we already know that if the map is not initialized, we will not be able to insert or update any key. So here I'm trying to insert or update, right? So that's the reason it's panicking. So whenever we are receiving any map, we need to make sure that the receiving map is nil or not. So we need to check if map2 is equal to nil. So then here itself we should return. So thereby we can avoid the panicking situations. So let's clear the screen, and if I simply run it, right, so it's not actually panicking. Instead it is simply like returning a empty map, and the same map is actually printing here, right? So this is fine. Now I am returning something, right? So instead of passing m1, let's pass m2 only. Okay, and now I'm taking m3, and I will try to add something to m3 now. Something like Zan itself will simply try to update to some 12. Fine. So now let's see like what it is going to give. It again panicking. So having said that, whenever we are like receiving a map, we need to make sure that map is nil or not, because if you observe at line number 25, we are like assigning this map to nil, and we are returning the same map. So here at line number like 13, we are receiving a nil map, and we are trying to add or like update some key to a nil map. That's the reason it's panicking. So we need to make sure that map is not nil. So if it is nil, we simply need to print like fmd.println of let's say like a nil map. And what we can do is os.exit here itself we can do, or maybe we can like add a if else condition as well. So both should work. So let's run it. Cool. So now it is printing nil map instead of panicking. So like you need to make sure, like whenever you are dealing with a map, right? So you need to make sure while receiving any map to a function, or while fetching or returning some map from any of the function, you need to make sure that whatever the return map or whatever the parameter which we are passing to a function, so we need to make sure that map is not nil. So if it is a nil, we have to handle it. Otherwise, the panicking situation will happen. Let's try to fetch some key which is not exist. So we have like a key like a Zan and Harry, right? So now we will try to fetch one key. Let's call it as like a Adarsh, which is not there, right? So we'll try to fetch that particular key, and we will see like how exactly it is going to behave. Oh my bad. Go run main.go. So it is printing 0. So it is actually confusing, right? Because if you see, the type is int, so whatever the like value type, so the default value it's actually printing. But it will confuse sometime, because whether it is printing a default value, or we have added a one key others with the value has 0 itself. There can be two chances, right? So every time we need to like practice using like if okay, nothing but value comma okay is equal to m2 of whatever the key we are trying, right? So and if it is okay, then we can simply print the value, or even we can print the okay as well, right? So nothing but this is the value if that key is present, and this is the bool value, nothing but true or false. If the key is present, then it will be true, otherwise it will be a false. Based on that one, we can identify whether that particular key is there or not there, right? So now instead of this, I will add it not okay just to print this line number 22. So let's see, go run main.go. So yeah, if you observe 0 and it is false. So nothing but that key itself is not present. But now if I simply add this same key like this, okay, now if I print it, that key is present, right? So let's make it to okay just to print the line number 23. So now it is true, nothing but this key is present and the value is 3, and the okay, nothing but the bool value is also true. So we need to always make sure to check using like if like a value comma okay is equal to map of whatever the key, because sometime it will print the default values. By that, like we can we will like will be under a situation that that key is present and the value associated with that key might be 0, or maybe it's printing a default value. So in such situation, it's always better to use in this way, because thereby we can get to know that key is present in that map or not. Thereby we can decide whether it is a default value or whether it is a actual key value which is present in the map. So far we have learned like maps are internally array of buckets. The lookup time for map is big O of 1. Nothing but like while inserting or deleting or updating, so the time complexity will be always big O of 1. And the number of entries in each bucket is fixed, that is 8. And the number of bucket always doubles, that is nothing but 2 power n. And the overflow pointer is used to point to a new bucket when an already full bucket receives a new value. And we also learned handling panic situations in apps. So if you guys have any doubts, please comment it out. I would love to answer all of your queries. And also, if you guys like this video, please do like, share, and subscribe. And also hit the bell icon to never miss an update. Thank you.